link to the King of Saudi Arabia. So everybody wave hi to the King of Saudi Arabia. And what grade are we doing in all this? What are we doing here?
This would be early middle school, like 6th or 7th grade.
6th or 7th grade?
Yeah.
Yep.
Yep. You could even do probably upper elementary.
Yes.
Mm-hmm.
But for our purposes, since we're secondary, it would be middle schoolers. So our lab today is called Water Olympics, and we're going to start by putting you in groups of 2. And I'm just going to have you work with your neighbor. So I think I'm just going to have you 2 work together here. And Jeff, you work with me. And so first thing you want to do is,
This table.
yeah, well, before we move to the next table, we're going to, Jeff, do you mind clearing your stuff off of this table here? So that's not, yeah. Go ahead and come up with a team name. Is that funny? Yeah, yeah, I just wanted to, since they're, and then this. Okay. Yeah. Yes. Okay, does everybody have a team name? So Jerry and Krista, what did you come up with your team name?
Army ants.
Army Ants?
Yes.
Okay.
We're the strongest animal. Is it?
And Jeff and Reed?
We're water rats.
We have an animal theme going here? Or, well, I guess water. I'm sorry, I'm afraid you're
We were Team Buttercup.
Team Buttercup, okay. Okay, so our first event is actually going to be at this table, but I'll have you stay where you are for now so that you can see the screen, and then we'll move to the table. So we'll start with the question of what do we know about water? So how about army ants? What do you know about water?
It's everywhere.
It's everywhere. That's it. Anything else? What else?
It's less than
It's
7.
what?
It's wet. Okay. That's the primary ingredient for life. Okay, so we need it for life, right? So how about, oh, that was Buttercup. How about water rats? What do you know about water?
It dissolves a lot of things. It's a solvent.
It's a solvent. Do we know anything else about water? Do we know anything about its properties? It's polar. Okay, it has polarity.
It turns to ice.
So it has different, so what do we call that? If it turns to ice, what's its natural form? Or what's its most common state? It's a liquid. So it turns to ice, it's liquid. Does it have any other forms?
Yeah.
So it has different states. Solid, liquid, and gas. Anything else? I think this is good to start with. So we're going to move, well, we won't move to the table yet, but go ahead and go to the next slide. Okay, so our first event is called pole vaulting over the top. So we're going to see how many pennies you can drop into the ocean before it spills over. So this cup will simulate our ocean. We didn't have room to bring the whole ocean in, so. So you're going to fill the plastic cup with water all the way to the top until it can't hold any more. And then 1 penny at a time, you'll drop them in. You'll record how many pennies fit into the cup before it spills over. So each person, if you look at your score sheet, you can read through the instructions again if you need more explanation. But each person will do it, 1 member at a time. Yeah, well first, before you start putting already full of water.
Are we filling the cups up to the point where it has a meniscus?
No, just level with the rim.
Okay.
Yeah. So you'll fill it level with the rim, so be careful not to overfill the cup. And then also, when you drop your pennies in, just hold it right above the surface and drop it. Don't like chuck it in there, and don't stick your hand down into the water. Okay? Don't touch the water. Okay? So you guys can go ahead and come over to the table.
Well, it's just gonna displace this water.
Okay, wait. Sorry, not dropping it. Oh,
Estimating.
Some serious estimating.
So,
If you have estimating, go ahead and use that.
yeah. I'm not overly optimistic.
There we go.
And I'll say it's 8.
Keeping it real.
We have to break the
Keeping it
I said one at first time.
So, okay, we're each gonna go through it, so we need to.
Yeah, so I put a towel, so when you are done, you can gently pour the water back into the pitcher to get your pennies out, and just dump the pennies out.
Like that.
Looks good, yeah.
Beautiful. Do you want to draw it?
Yep.
We're not supposed to have the penny in the water when we release, correct?
Yeah, just drop it. Yeah, you don't want your fingers to compromise the surface of the water.
Put 5 in?
Yep.
This is really fun, right?
6. I didn't get it very full to start with.
6.
There's not much displacement.
If you run out of pennies, let me.
Okay.
You get a handful.
12.
That's 2 at once.
What number were we at?
We can always have a first.
Okay, good idea, because I'm not focusing right now.
So how many people are past their estimate already? So what do you notice happening to the surface of the water?
It's bubbling up.
Yeah, it's pretty bold.
Oh, Anna Montana. Effort. Adequate.
There's 40.
Oh, that's
Yeah,
sick.
take a look at it from just at eye level.
Can we steal some pennies?
Wow.
Did you run out?
Yeah. Thanks, Reese.
If your group runs out of pennies, see if you can borrow some from a neighbor. My bag's filled with cars that I lost. Oh,
I gotta be close.
Oh my.
There you
Got it
go.
all at one point.
53.
You need your pennies.
I need
You know,
some pennies too.
I thought I was almost when we started.
Yeah.
But
Did
we
you-
are.
No, that was.
Oh, you need those
Well, we
pennies?
can like a quarter inch.
Yeah.
I mean, almost.
Can you slide that picture over? So I'm gonna.
Wow.
Here, mix. You should have said something about pennies, because I have a whole jar of them.
Well, my bag fell over in the car, so I have more, I just have to fish them out of the
You
bag.
know how many pennies you have in your cup? Because I'm stealing from your cup.
Oh, go ahead. Yeah,
okay.
we had, well,
Here, you
we had
keep going,
53.
keep going with yours. If you guys are done,
So I guess you
Did you
guys
run out of
go
pennies as
on
well?
your.
Yeah.
okay, here. Oh, but you're done.
Yeah, we need to do our second now,
Okay,
because each member's gonna run the trial, correct?
okay, yeah.
Okay, so Reed's gonna get it, go here.
Ah. They were going to cry.
So did you get up to 60?
Yeah.
Jocelyn, did you hit
We got
60?
59.
59.
Yeah, because it's, each time it's filling.
That's amazing.
There.
That's a meniscus there.
So how many did you get to?
We don't know.
You don't,
I stopped counting.
We could hedge
Drop
this
the water
by.
and then count the pennies.
Okay.
And I know how much from their team
With a
we
good
took,
gap
so.
start.
okay.
We might, if you can, you're real careful, we might get 10 pennies is all, if we can get a good meniscus to.
Because you're not supposed to make a meniscus, right?
Yeah, try to do it about the same.
Pre-
So you can
okay.
compare your results to your partners.
Okay, yeah, we're a hair more than what I had.
Oops. Lord. I think there were some already in there. Oh,
Yeah, that was mine.
Okay, there's 2 in there
On your
from
clip,
the
read.
So for,
I
for
quit.
Team Army ants, we will just record one.
Wonder if that is, these are
Eleven,
wet.
so we'll just have to.
yeah.
do it,
He drops
and,
in water.
You can make a close guess.
You
That's
guys could have
tricky.
made 59 wishes.
You know, Reed's got a good point. These pennies are now wet, so we're actually adding water as we add pennies.
I guess try to dry them off.
That was
Unless we
awful.
dry it.
I'm sorry, I really dropped the ball.
That's fine.
Let's just put greater than.
I lost count. Reed, where you
Oh,
at?
that's very-
Well, I'd say you guys are about as rowdy as middle school students.
Yeah.
Nice, it's 50.
Yeah, we do.
Greater than.
We're gonna do another cooperation.
Yes.
Alright.
I don't know, I still stand from bottom, because I'm really on the
Oh,
ball.
they're
Did you
pretty
fill your
dry.
cup again? Okay,
You know,
I'm gonna
they're
pour this
not
water out to
perfect.
get the rest of the pennies out. There we go.
They were dry on one side. They're dry on both sides. They need to do a lot of. These are all pretty dry.
I think you guys are spilling over, yeah.
We are.
Do you think, well,
Go ahead.
33? Yeah, I got it.
Yeah.
Maybe we're 33.
Should have been Team Bowie.
26.
I know how you love Team Bowie.
Yeah.
I didn't want to steal that option from you.
Well, we definitely had a meniscus starting on the top on this. Right at just
Well, I
under
think we had a little
half.
bit of a meniscus.
Yeah, I think I put this one.
so has everyone gone through both trials?
Yeah.
Okay. So I'm gonna go ahead and put the results for each team up on our score sheet here. So we'll start with the Army ants, and I think you just
Greater
have.
than 50.
I think I just added about.
Okay, so your
60.
first one you'd say it was 50 plus, and then the second one
60.
60. Okay, water rats.
We had 53 and 26.
And buttercup.
59 and 33.
Okay, so it looks like Army ants was the most consistent in the results, but can you guys give me some kind of hypothesize why your results would have been so different? Because it looks like we started out pretty even, 50 plus, 53, 59, but our second trial was quite different. Any ideas why we might have gotten different results the second time?
Filling it a little bit more full, like.
Yeah, if you
We had a
were,
higher meniscus.
right, if you weren't careful to fill the cup to the exact same height when you started, so maybe you started with more or less water in your cup. And then also, the water rats had a good explanation for that as well, that because the pennies were wet in the second trial, maybe you were adding more water, yeah, with the pennies. So who was shocked at how many pennies actually fit in there? Yeah. So who would have ever guessed we could fit 60 pennies in a cup that's already completely full of water? So that brings us back to our question here. What does this demonstrate? What property of water is this showing us, being able to add the pennies to the water? Surface tension?
Polarity.
Just volume, I guess.
Jeff nailed it. It's cohesion. So one of the properties of water, because of its polarity, the water molecules are what? They're attracted to one another, so they stick together. So this lab showed cohesion. Okay. So do you want to?
Second one?
Yeah. So go ahead and move to the next table, and then look back up at the front, and we'll go through the instructions for the next event. Do you want to do this one?
Okay, the second remove will use the boat, and we will put some water over the thing, and you should account how many boats you put in the boat spread. Okay?
Now, before you start, I'd like you to do the same thing as the first event. I want you to make an estimate first of how many drops of water you think will fit on the surface of the penny. And then also another thing, just like the previous event, you want to be careful not to put your dropper onto the surface of the water because it might actually draw it back up into the dropper. So hold it directly above it and drop one drop at a time, counting how many drops will fit on the surface. Okay? So make your estimate first.
I don't know, I think that side's a little
Should we
more flat.
say
I think this
15?
side's more
It has a little
structure.
more, it has a little more raise to it,
Yeah.
so we might have better success. Will you do one? Are we gonna?
And each team member
Okay.
will do their own trial. So again, it'll be 2 trials. And like we discovered last time, you might want to dry the penny in between trials to make sure there's not already water on the surface.
Oh,
Like 6th graders are always so excited when their estimates are, or their hypothesis is right.
Let me guess, 15.
It's exciting.
Yep, 9.
Now, as you're doing this, you can also stop to make some observations, or you can sketch
7.
what's happening, what it looks like just before the water spills over.
Ah, sure. It was like almost doing that, like already over the edge. So I had changed my guess to 25. So it's
Still
almost
what I
like
said.
arcing over the edges a little right before it spilled.
There.
Really
Try on the
was.
other side.
Right.
That's a very lovely picture.
For
It should be in our pages.
spilling. Alright.
Watch the
You wanna
wind.
try
You're
the
about to blow my
Sure.
Reed's meniscus off there. That breeze was
Of
about
course,
to
I don't know
blow
if we
it.
want 2 even trials and then
Oh,
maybe
wow.
an extra variable there. We'll make note of it.
That's amazing. That's how I like that.
I think you can keep going, Krista. It looks like it just kind of missed the center there.
That is. This is good enough for a good drink on top of that penny right now. Wow.
Huh? Yeah, well, it was off initially, so
Oh, yeah, so
I keep like feeding it.
I can't remember what number I was at anyhow. It was interruption.
14.
Cool.
For
Yeah, so
heads
first,
has
do you
a
want to
distinction.
try yours
Oh, yeah,
again?
you can do
Yeah,
heads.
I'm gonna try
Yeah,
it
I'm
again.
gonna try the heads.
Did you get over 30, Jared? Is that what I heard?
I got 31.
I'm really skilled at putting water on pennies though.
Just steady.
That's what we're gonna describe. That's
Nerves of steel. Even works.
Sometimes scary.
What was your estimate?
15,
And how many did you get?
29. Nice.
I was at 20, right?
So what was your 25? So you guys were really close.
Yeah.
We even flipped it.
Got 20 on
So
there.
I'm gonna write
Yes.
tails.
Tails.
Okay.
Heads.
And why did you decide to?
That was
Depending
unfortunate.
on the
I think
imprint
you're gonna have to
or
redo
I
that.
think I am.
the whatever is on
Embossing on
the
it.
yeah the embossing, it might change how much
Change.
work.
Because that drew it right off,
Yeah, it
didn't
did.
Yeah,
it?
because that's gonna take up some of the spot. Space.
There you go. Oh,
Actually,
What,
I gotta make
35?
sure we're
Mhm.
dry. Hate
Oh,
yep.
to draw,
So 35?
draw off
Yep.
sides.
Ah,
I didn't know. I didn't try it.
Is anyone still working on
No.
this event?
I wonder if
We got one
touch the
person.
drop.
Chris, are you done or are you trying
It's
to?
drawing more water.
I'm
No,
done.
I'm cleaning up.
You're cleaning
My
up.
drop.
Oh, okay.
Yeah.
Oh, is Jeff
Just
still?
letting it drop.
Jeff's still got one, yeah.
Okay.
looks like he's almost done.
so where were you looking?
I think that's too much.
Get more water too. Looks like your drops are part here. There.
Three.
Wow. Okay. All right, so let's record all of our team results again. So Army ants,
31 and 35.
31 and 35. Water rats,
29 and 43.
and Buttercup.
27 and 28.
So we got some varied results here as well. So were these above or below your estimates? Before you started?
Very close.
Yes, right above.
So we have one group who says there was close. Your estimate, so you are Buttercup here, right? So your estimate was 25, and you guys came pretty close, 27 and 28. How about water rats? What was your estimate?
Oh, 15 and 12.
So you went well over
We
your
were
estimate.
3 times.
And how about Army ants?
He said about 10 or 15.
Oh, 10 or 15 drops, okay. Does anybody have a theory as to why these numbers might be a lot higher than the rest?
Heads, tails.
I had heads. I used heads.
We also flipped it heads tails and we got similar results.
Yeah, so Team Buttercup intentionally flipped theirs over because they thought maybe the embossing on the coin might change how much water would stick on it.
I'm just thinking like,
Which was heads.
my sixth graders actually worked with droppers today and we had them purposely use the same person in both trials to do the dropper.
Yeah, that's
Because
what I
depending on who
noticed.
you are,
If you don't
yeah.
squeeze as hard on the dropper, your drops might be smaller.
Yeah.
So I noticed that with Carissa's, you had the highest number, right? You had the 43.
Or I had the
Oh, you
highest,
did?
yeah.
I think, I don't know, yours was 35. Sometimes the drops may have been a little bit smaller, so it kind of depended on.
I don't, there's mine were a little bit larger than yours.
Okay. So we had talked about this idea of cohesion with the first one. What is different about this second event? We saw it sticking to a penny. So if you drew that, it looked something like this. You had your water bubbling over the surface. So here, this is cohesion. That's the water droplets sticking together because they're attracted to each other. But what happens at this point right here when they stick to the surface of the penny? Adhesion. So water molecules are not only attracted to each other, but they're also attracted to other surfaces. So what are some other examples of adhesion that you would see in everyday life or in nature? What are bugs?
Mud.
Water on a glass, inside a glass.
Right, water droplets on the inside of a glass. What about raindrops? Do they stick to stuff? Or morning dew? All right. So I think we'll go ahead and move on to the third event then. And so let's go, actually stay where you are and then, I'll go ahead and have you move to the next station before I give you the instructions. Okay, so this one's called sculling, bubble power. So the instructions for this is there's a template already cut out that looks like this little boat pattern on your lab sheet. So each person in your group is going to get a piece of cardboard, and I'll grab another pair of scissors. You'll cut out the little boat template with the cardboard, and then you're going to get a chip of soap and put it in this little cutout notch. Then you're going to put your boat in the water and see what happens. So again, be mindful of how you put this in the water. Don't push it into the water, don't throw it down. The soap might fall out, so you just want to gently lower it onto the surface of the water. Okay? I'll grab another pair of scissors.
We have to eat.
I moved them over here.
Oh gosh, then.
Little face.
The instructions say
It's
to
gonna sing.
continue. Let me see. So once you've tried this initial design and tried out the boat, the instructions tell you to go ahead and try to come up with your own design to see if it improves the results for your lab. So I think there's enough cardboard here for each person just to do one additional design. Well, they'll use that for the first one. So they'll all be the same on the first one. The second one, they can create their own design.
Is there a reason the timer is small?
I don't think we have enough supplies to try. So the idea was to, everybody creates their own design and then you can use the timer to see if it changes the speed.
Oh.
But we don't have enough supplies for everybody to make several designs and do several trials. So I think we're just gonna maybe forfeit the timer.
Does that mean we're forfeiting our own design?
No, you can do your own design. So if you would like to, I guess you could do your initial time with this. Okay, let's do it that way. So Carissa asked why the stopwatch is on the table. So if you want to time your initial design, which is this template, and then make your own design and time it and compare to this one.
Can we make our own design three-dimensional?
Oh, yeah.
I don't think there's enough. I think there's only one additional cardboard, and unfortunately the size is not that different. I left my house without the extra cardboard today. When you put the soap chip in also, make sure that it doesn't rub the bottom of the pan. All right, we've got one soap-powered boat.
Should we do a wall? Okay. Eco-friendly.
Okay. So this is what we're after right here, Mohammed, is
Oh,
okay, well, I think I'll have a race with
Oh,
three,
okay.
too.
check that out. Whoa. Oh, you're going the wrong way.
They might not go in a
You're going
straight
the wrong
line.
way. Bam.
So you're saying it might not go in a straight line, so that may be something to keep in mind when you design your
Because
own.
I
It is
just
just
said
mine.
If you change the shape of it, if that would.
Yep.
That's gonna be my,
So,
oh my.
it's good.
Oh,
Wow.
great.
Take
The
off.
marker, so
Oh,
Sabotage.
What'd you do to that soap?
Physics.
look at that.
I'm pretty sure Reed won the boat race.
Whoa, I missed this.
Well, Chris hasn't tried yet. Maybe
You
you
think I'm
best
on the
read.
bottom?
Yeah.
Oh, I think you're right. Reed, you probably want to just re-enter your same boat in the next race.
I'm
Yeah, we gotta get rid of some of this. My, oh my.
banana boat.
We got a lot of. And now it's curved up, so it barely gets into the water. There it's going.
Oh, now it's.
You're gonna get so many tracks.
So if you want to Reed, if you want to make a new design for your second trial, and it's kind of hard to time if they don't go in a straight line. So if you don't want to record the times and compare speeds, you can do it more visually. Obviously, your first boat was pretty quick.
That was a great speedster.
And you know, you have some large pieces of soap in your water. You might want to take them out because that soap in the water might compromise your experiment there.
Definitely get a cupping on those boats for hydration on the inside of the cardboard.
Yeah. I probably should have used a thicker.
no, like what's that movie at all or something?
Yeah. Well, I don't know. That was a great example of reeds.
I thought this one was easier to cut out, and I just kind of rated my
Like,
recycling.
I'm kidding, but whatever.
I'll maybe get my soap place.
Yeah, mine's dead.
Yours did yours ever move at all?
Not too bad.
No.
Those sodas.
So
It's hard to beat what Reed had going.
Oh,
Had a little more
that
aerodynamic.
surface. Alright, I like it.
Yes.
I could steal Reed's soap piece.
oh,
That's
nice
what
boat,
I
Chris.
2, 3.
Of course, we might not use. I used a very small amount of soap. Oh, goodbye. Goodbye.
Oh, she's taking you out.
I'm like attacking your ship.
Go, buddy.
Oh, I'm
Really?
like circling
I'm
around
taking
you.
on
Like
water.
I'm doing a victory lap.
I gotta start bailing it out.
Oh, make this smaller.
I need some life jackets.
Circles do not work.
They work good for going down hills in the snow, but maybe not.
Did yours not go again?
Oh,
Maybe
Reed's
try
got a design
moving
going
it
here.
soap a little bit further into
You
the
will make-
water. I'm surprised that it's not moving.
Put more
Oh
soap.
my daughter, she couldn't get it.
Yep.
More
There it
engines.
goes. I think you just need it.
Okay, let's see if this thing takes off.
As a writer.
Oh. Ah.
Oh, good idea.
Am I back heavy? Look at this guy. He's trying to get out.
And then try adjusting your soap chip and see if you put more of the soap in the water. If it will
Good for you.
Goodbye now. Not everybody can be as good as me. I'm sorry.
Some modest too. That's what makes it.
Got a little bit of movement.
What makes losing so great to you.
Yeah, so let's try something different.
Do it, boat.
Oh yeah.
Okay, that should turn.
This is like a shoe.
I don't know what else not going.
We've
No
got
matter
them all
what I do,
kinked to
it's
the
like.
side. Let's see if that makes any difference.
All right, it looks like we're waiting on Reed's grand finale here.
Oh.
See how
Oh,
fast.
we don't have time.
See how fast his speedboat goes. Let's see if you can beat your first one.
I'm not an engineer. If I was an engineer.
All right, Jerry, you're cut off. That's the second
I
time
need to
you
stop playing with water.
Is there a towel at this table?
Well, you went for a tiny little guy, Curtis.
Yeah, but it's probably because Jerry moved the water around.
She made waves. Sorry.
I
Do
was
you want it?
stirring
Oh, no,
it.
Oh, look at that.
No, it's fine.
All right, we do have one more minute to perfect your boat. and we've
Trying
got
to make it
move on.
more like
We don't
the
have to
ocean.
wait.
There's ocean waves.
You have to.
No, we
I
can't.
want to
Sorry.
see what's unique
Just
about
don't
this
get your
piece of
paper
soap.
wet and we'll worry about cleaning it up.
Because this soap, see, he's only in that far.
Poor Chris
And he
is
just
not-
took off.
Well, we didn't define
I did that.
He's got, it's like an ice, or it's like opposite of an iceberg when he has the
Maybe
tip.
less drag from the soap.
All right.
So let's see. So
Well, I think that one's
Whoa,
going
now
under.
that-
This is the Titanic now. He's
Your
going
boats keep getting
down.
smaller.
Well, it's them using the extra pieces, but it's not doing
You're not your big piece in the middle that was super efficient.
That's a pretty nice piece.
It was.
Now it's going.
I don't know if you dare use a wet piece or not.
They say Titanic.
Oh, it just broke.
Do you need more soap?
Here, I'll just-
I see. We're going for like jet power.
That's
here.
that was the idea.
no, I didn't. I'm just cleaning the table.
Yeah, I don't know why. They just
I keep hitting it, and I'm just.
Tell.
Okay, Jerry, back away from the table.
Before
I keep trying to like fix it, and it just makes it worse.
I RC shower today, so I don't need a second one. Thank you. So.
Switch down to 6 scooters. This is what happens.
We're learning about ocean.
All right, ready for the grand finale?
This is better impression.
Yeah, this better be good.
It's gonna be so miserable.
I
It
hope
looks like
it's
this
six.
section.
Yeah, I think that might have made a difference. So, and we'll talk about that.
Where did this go?
Oh, it's under here.
So spilling everything on.
Well, just in case
It
this
wasn't such
happened.
an important engine.
Engine runs down. Abort, abort.
Well,
All right, the
this
pressure's
is
on.
quite a boat.
I know.
Look though, what is this? So nice.
Those wide wings vibrate. It's hard to keep that.
Oh, just let it go. I say that was fairly anticlimactic.
It's a hydrofoil. It's just
I think you
disintegrated.
lost too many engines
I think
there.
so too.
All right. Let's
Sorry,
go
Pete.
ahead and turn our attention to here then. And so we don't really have anything to record for event 3 because we didn't time our vote. And we already know that the water has these properties of cohesion and adhesion. What kept that boat afloat? Adhesion?
Density.
Surface tension of the water.
The surface tension is what kept it on top of the surface of the water. So what made the boat move in the water?
So,
The soap. How does the soap make it move?
is it,
Breaking surface tension.
It makes the soap molecules not always stick together.
So the soap, and Krista, can you say it again, how you,
It disrupts the surface.
so the soap actually, it disturbs the bond between the water molecules. So there's no surface tension where the soap is. So actually, Carissa, can you describe what you were doing to try to get your boat to move further?
I was thinking of the piece of soap behind it.
So she was using additional soap to try to help break that bond between the water molecules. So if there's no surface tension where the soap is there still surface tension around the rest of the boat?
There's like
There
a
is.
front.
So on the front of the boat, you still have surface tension. On the back, you don't. So that causes it to be pulled or drawn through the water. So that's what causes the boat to move. So we've talked about these properties of cohesion, adhesion, and surface tension. Okay, for our fourth event, we're actually going to have some special guests introduce the instructions for this lab. So event 4 is clipping along. How many paper clips can you suspend on the surface of the water? So can you go to the YouTube? And then, let's see. Yeah. So these are your instructions for event number 4. Uh-oh.
Turn the sound
You
up.
turn it up.
The sound is on the wall. It's on the wall.
Dial.
Great. Okay, now.
A container full of water and paper clips.
So what is Wade going to do there with the paper clips?
He's gonna try and see how many he can make float in the cup full.
And what technique is he going to use to try to float the paper clips?
A hand lens or a magnifying glass.
Okay, we'll do that next. A fork. And why do we need a fork?
To gently put in.
Very good. All right, give it a try. It's okay. Sometimes you may need to practice your technique a few times.
After you've put a few paper clips in the bowl filled with water, observe them with a hand
Lens.
lens or magnifying glass.
And then after you make your observations with your magnifying glass, what are you going to do?
Write them on your
Lab sheet.
lab sheet.
Once you've written these observations or drawn a picture on your lab sheet, you can continue placing paper clips on the surface of the water, counting to see how many paper clips will float on the water before they start to fall to the bottom. That was too much script for her, so. So we'll move to station 4. And again, before you start, go ahead and make predictions of how many paper clips you think
How
you'll
many
be able
paper
to.
clips do you think, Reed?
I'm gonna go with about.
On the same size, because the container.
No, I might
It
see.
seems like it was attracted to the fork as it dropped it.
Yeah.
Made it a bit difficult.
I'm gonna grab another thing of paper clips for this.
Safety pins.
Well, they definitely
They're
have a
different.
density that's
Different alloy.
greater than water does up there.
Sure.
So obviously they
And
will.
if you run out, you can borrow from another group. I think you guys should be okay though.
A little blurry.
So you practice your technique a few times because you have to kind of slide the fork out from underneath
So
it.
what do you think?
But they will
There's a
float.
bunch of those would fit in, but they're gonna almost have to touch each other.
And like.
That's true, and I think as soon as they touch each other, they just sink.
So I'm gonna call 15 myself.
15?
Not much you.
I'm gonna go 25.
Ooh. Okay.
Oh.
Go big or go home, right?
Yeah, you have to, you need to lower it down, yeah. If you put it vertically, it will just sink to the bottom. Technically, that food is the
Can you
traditional
get
definition.
efficient? Do 2 at a time.
You can try it. I don't know.
Be successful.
Look at
Just
them
dropped
all
it.
stick together, that's
Yeah.
kinda neat.
And we find each other.
Nope. 2 at a time was not successful. was.
So, somebody mentioned this earlier from army ants. What do these paper clips remind you of in nature? What do we see?
The water skipping
Yeah,
spiders.
the water striders.
It's really, never really move like a
If
dish
you tip
soap.
it up, drop it right away, it doesn't fall the heels so much.
This one do the big
Oh,
one.
wow. That's good.
We're developing.
Oh,
This is like operation.
No.
It's like
Do you want to try
operation.
this?
I think we'll do 2 trials.
I think
Holy
we're
crap.
just-
Yeah, we'll do 2 trials again, so each team member will get a chance to.
This one doesn't want to play.
Was it a different color?
No.
'Cause I've got a gold one here.
I think
haven't
that
tried
Jerry
yet.
may need to practice her technique more.
I had it for a while.
Dude, that's why I said like 5.
I just got too sure of myself.
Yeah, that's true. 'Cause see, we do have a gold
Bro,
one
it's
going
a
now.
big one here.
So keep a tortoise
Yeah,
in
keep
hand,
going with 20.
but slow and steady wins the race.
Which is why I only said 5. So I can just more.
Oh, I lost one.
Yeah.
When I start losing them, does that mean I'm out?
No, I
If,
think that-
if you think it just fell to the bottom because of your technique of lowering it, but if they start consistently
Yes.
falling one at a time, one after the other, then you're good stuff.
Because it came off the opposite side of where I attached.
So you can't very carefully do this.
Yeah.
I think your fingertips touching the water
Okay.
would disrupt the surface tension enough to.
Should I try it with my acrylic?
You could try, sure.
Is a bent safety.
Bam!
That might
That safety pin was cupped, it was bent, and when I put it in so that the cup went down, it wouldn't hold. I had to go and cut it up.
Kids are
Way
cute.
easier than a fork. Just get some acrylics, y'all.
I wasn't sure how that would go, but I thought that would be pretty good.
Yeah.
With the instructions.
Oh, I've lost 2 now.
Oh, they like follow the fork.
I think so too.
Probably got some juice.
I lost 3. I'm losing 1 for every one I add now.
That's right.
It's me? Okay, that was me. Way too fast.
And that guy.
Shit.
So I think, Jeff, if you're consistently losing them, then I would
think
say.
that's probably
you're
about
probably
it.
done. So you can fish those out and then recharge.
Yeah.
Can't believe it was floating was,
Yeah, 7. Definitely not 20.
well, that's
No.
all I really got floating.
I think you're gonna start losing.
So I can do it and I have acrylics.
You might want to use those dry ones because it seemed that the water inside the clasping mechanism, once they
Well, and
sunk,
if you'd like to try paper clips next time, you can. I didn't think I had enough paper clips, so we just grabbed this. Do you want to try out there on the paper clips instead?
I just
See if the shape changes it?
Yeah, I guess we should.
I can share. I was grabbing dry
In
ones.
the name of science, you can try.
Sharing is caring. It's hard, isn't it?
Oh.
You're there.
You got a bundle going.
Oh, I think that's.
that was-
Yep.
Oh, I think you found out your number. So 2 just dropped. So
Yeah, you're maxed out.
So 14.
Yeah, I don't know, because 2 dropped out.
but you had
Yeah,
4
but
in
they
the
were
first
floating
set.
initially, and then they fell.
So.
And don't forget to make some observations about the surface of the water with the paper clip in it.
they're subsurface, aren't they? They're sub-meniscus.
Layer 7.
The center of all.
And on the outside.
Nothing. 6.
Ow.
Never
They're
said
kind
that.
of hang out a little bit.
So Reed, when you put them in, you have to lay them in fairly flat because if they're
Yeah,
too
it kind of looks
long,
like
it just kind of
cuts right through this.
These seem tougher than
Then you have like a
the
bubble
safety
on the
pins,
outside.
actually.
And I tried, I used these containers because it was a little bit wider and flatter than just a plastic cup, that it was easier to get the fork in there further, but
Yes, a little bigger
yeah.
circumference here. Anywhere.
You could try it.
Nice, there you go.
That was it.
I had pretty good success with
Just out of curiosity.
pins going across like that and dumping, but these just seem a little more fragile.
But no, it's not gonna work. Just let me try it.
They take up so much room.
I can get it out of work.
You can try using your fingertips. It'll be easier to get in there.
I wonder who has thinner hands.
Mine
I don't know, is that a
particularly
gender? I don't know if that's a gender
Nine?
difference or
Yeah.
not.
Just wondering. There's a lot of male
Who are the
surgeons.
most common
I think it's
surgeons?
patience.
Yeah, that's what I was thinking.
Yeah.
I don't, that's probably gender specific, but not because of
That's
steadiness
steadiness.
of hand.
Could be. I think it's more focus of, I mean, obviously it's varied throughout, but, you know, a guy's
11.
ability to focus
I'm
on
running out of
one thing
room here.
is maybe what drives some of that. Not that women can't, but
I drink too
Well,
much coffee to have.
yeah.
Sorry.
Oh, you got a good thing going.
I get too frustrated.
Yeah, I start with 12 floating.
14. Try again, because that one just fell off.
So I can still count that as one point.
away.
Don't count it as one floating, but don't try to fish it out, because then you can drop it on floating.
But
And yet it
I think
seems
next
on the
one,
drop
I had
side it
15
draws
that
to
was
you.
floating at some point.
Oh,
Oh,
wow,
it
look
was.
at that jump.
Okay.
These creme brulee.
Yeah, that's what they look like.
Ramble.
Oh, yeah.
It's so easy. It just takes a long time.
Yeah, they're.
I think 14 is my number.
I use them for
I use them for spinach.
I ran out of
orchard
space to do it right.
and
See
creme
how
brulee.
it pulls to the fork, and yet on the back side it tends to push away.
I think I accidentally sank that
And
one.
use that to.
Yeah.
Sorry, let me get out of your way.
Oh, I think I can keep sinking it. I don't think
Here,
this
I'll
is enough.
help.
I'm gonna break my surface.
I love your drawings.
What's going on there?
I think they must be charged up a little bit. Oh, where to dry it.
I think that's a
Yeah,
good
I think it's
observation,
cool.
Reed,
Yeah.
I bet in a
that they
more humid
repel off of
atmosphere.
the fork once they're stuck together.
I have no idea why, but this is what I used to get when it's like.
Yeah, to push them, you push them out of the way so that you can.
And use the side to steady your fork.
Well, I think my strategy is to get the fork out of there quickly.
You know, one advantage of the safety pins is that they're
That
smaller,
way they
so
don't
you
turn
could
to
get
be a
more.
I think you've exceeded, you've just got two off, so.
The safety pins took up less surface area, so you had a little more advantage with the smaller pin.
Yeah.
Okay, at 9 or 10.
Mine is the most.
Two drop dice.
Yeah, that 10th one, yeah, you lost one.
Yeah.
right, I think everybody's finished, so go ahead and add a drawing and write down any observations. And then we'll record the data together. Are you still going?
Almost done.
Oh,
14, but I think I'm gonna drop. Or did I sink it?
I couldn't tell.
It kind of looked like his tongue.
Oh, yeah, we were supposed to use our lenses too. Your daughter was telling us to look at them with their lens. And that was maybe to come up with the fact that they were recessed on the meniscus.
Yeah.
Kind of like
It
what
is
I
kind of
do here.
interesting, you can see the water actually coming up over the sides of the
Around the end.
And from different angles, like from where I am, just because of the light, I can see that.
You really see
very
the,
clearly.
the clip sunk. Ooh, nice.
15.
14. Just a
Oh, 14.
Inflating your numbers.
Cheater.
I'm gonna try something here. Just
Okay,
a
there we go.
draw.
That's 15.
See how it pulls to it here.
There we go.
Now here.
So take just a minute to make a few observations on your sheet.
All the drawing.
So that's what my little arrows were
Oh, yeah.
kind of for here. This close one on the inside intended to draw to the handle. And other side intended to draw back.
So you only got 9 in with the paper clips?
Yeah, it seems like they're so much bigger, they take up more surface area.
Yeah.
Mm-hmm.
Which, wow, I was having a hard time fitting it as many as I did. I'm surprised I did. Because
See, now it's drawn.
Yeah, that's better.
Now, pushing. It has to have,
the
it
line
has
of
to
the
have some
water.
current or some magnetic field going on.
Okay, let's go ahead and record our data on our score sheet. So we'll start with army ants. So first, what was your prediction?
5 and 20.
5?
I said 5, she said 20.
Okay, so you said 5%. What did you actually get?
She got 7, I got 14.
So you're
Okay, so Jerry's prediction was 20, but she got 7. And yours was 5, but you got 14.
I was going with the trend.
Okay. And water rats.
We were, let's see, our predictions were 25 and 15,
Okay.
and our actual was 12 and 9.
And Buttercup. Team Buttercup.
14 and 15.
Was
Oh,
your actual numbers?
yes. Sorry. And
And
our
what
get
were your predictions?
12.
Okay, so you guys were close again. You guys have been consistent throughout
Yeah.
this whole thing. You must know more than everybody else. So we have a little bit of variation, but for the most part, it looks like, you know, this is pretty consistent numbers. And one thing that we did observe is we were using 2 different types of materials. We had paper clips and safety pins, so that could have affected some of our results. So what happens at this point when they start dropping off?
Seems like
Any guesses?
they multiply. I'd have one drop first, and then I'd try another one in, and then I'd get 2 to drop. And I
And
saw
you get
that
2.
happen several times.
So what is causing them to float initially? So we talked about these ideas of these properties of water. It sticks together, it sticks to other surfaces, and it has surface tension. So what does surface tension do? What is it? Can you describe it?
Keeps the water, holds those together with it. So it allows water parts to sit on top of it. It's almost like a thin sheet of fabric.
Okay, that's
of
good.
water.
Can anybody elaborate on that? So the water molecules are attracted to each other, they hold together. And so another way to describe that could be kind of like a film or a membrane. And it has a certain amount of strength. So it's strong enough to hold the paper clips or other objects that might have more mass or more density rather. Because of the strength of the bond holding the water molecules together. So I think once we got to this size, it filled up most of the container, right? So when you only had a few in there, there was still quite a bit of surface tension left in the container, but as it got more full, you're taking up more and more of that surface tension, so that bond between the molecules isn't strong enough to hold the numbers that go above 15. And I think that we would find that if we did more trials, that would be pretty consistent. Somewhere in this 14, 15 range is about as much as it can hold. So what do you think would happen if we put it in a smaller container? Do you think it'd still be able to hold 15 paper clips?
No,
Why not?
smaller surface area.
A smaller surface area. So if we put it in a larger container, then we would be able to hold more paper clips on the water, right? Because that membrane would be stronger when you have more surface area to cover. So I think once you get to, it's probably proportional, the amount of surface area that's covered with the paper clips, and it gets to a point where it just exceeds the strength of the water molecules, and then they start to fall. And I think that's it for event 4, right? So we can move on to 5. And again, go ahead and move to the next station. But before we start, we'll go ahead and watch some more instructions. And these instructions are a little bit longer because there's more steps and with a little less editing. So you just have to ignore the big brother, little sister dynamics. Action. Okay, ready?
For this experiment, we'll be using 3 kinds of paper towels. A napkin, a Kleenex, and a colorful napkin.
Okay, and we have already cut out 3 strips, one from each paper. The first one is already attached, so you put the paper towel into the container. Now you're going to check the side and see about how high you need to fill it up so that 1/2 inch is covered with water. So Wade, what line do you need to fill it to?
To the 50 line.
Okay, so now what are you going to do?
Now, I will take this out
Very good.
and pour the water to the 50 line. Then I will put it back in. And remember, this is napkin.
Right, that's the napkin. So now what are you doing?
Now we are looking to see how high the water goes up it.
Great, so you're going to watch that, and then when the water stops traveling up the napkin, you're going to remove it from the container and measure how high it traveled.
It went about 2 inches.
So the water traveled 2 inches up the first one, which was just a napkin.
Next, we have tissue paper. Achoo.
Okay, before you put it in the water, since we're trying a new type of towel, we need to empty the container out.
Oh yes, good thought. I want it. Now, we are going to put in the toilet paper, tissue paper. It goes up to the 50 line. Now, we'll take it out and pour the water into the 50 line, just as we did the first time. Now, we'll put it back in.
then you record all 3 measurements in your data table and make comparisons of the different types of towels. Okay, so the emphasis in the instructions for this is that you need to measure how high you would like your water line to go in between each trial. So you have to pour the water out and then pour it back in each time, because you may not cut your strips of towel the same length. And you want at least half an inch of the towel to touch the water. And so before you actually do any water, you have 3 different types of paper. So just a regular dinner napkin, a piece of Kleenex, and then this, I think this is like a 2-ply and this is a single ply. So if you unfold it to cut your strips. And so make some observations about the different types of paper towels and make estimates on which ones you think would be more or less absorbent, or which one would allow the water to travel further up the towel. So, oh yeah, I'm sorry.
Agree.
Can't tell if
That's a good question.
tissues are pretty absorbent.
Would you like us to fold this out to single or to use it double?
Keep that one double.
Keep it double and
Yeah,
this will be single.
Yeah.
Okay?
Tissues better. So tissues thinner.
So we need to make some
Colorful.
forecasts, don't we, here?
I feel like this feels
Well,
like it's got
This
stuff.
one.
Kind of. Yeah.
Oh, we need some links. Okay.
Yeah.
That looks like it would work better.
So predictions.
Well, let's see, observing the napkins,
So
we definitely have coarser, spongy napkin compared to this. This is near a sponge. So maybe that's a good observation. And that's going to be too
Do we
far
have
also.
to, are there certain dimensions in all this stuff?
And then compared
do you
to,
measure
this is definitely
I just measure them in centimeters. I think I put centimeters.
No, it's only good on this.
Are we doing 2 different trials for each or
Boards.
just one?
Are these supposed to be the same size?
tissues.
No, that's why you measure how high the, so all that needs to be consistent
One
is
characteristic of tissue is definitely
that
soft.
only half an inch of the towel goes into the water on each trial.
Either napkin.
I got the size stuff out of it.
Yeah.
So this time it goes up to, you want half an inch?
So, we're gonna make some predictions.
Right now, it's to like.
For a snap.
And in this one, you'll just do it together as a group rather than doing it, take it out first so it doesn't get wet.
I'm a little uncertain about these two.
Fill it to like that.
This is,
Between 150 and
the
200.
softness is great. Just my
Well, that, I agree.
This would be a course, color.
Yep.
Okay, and it was a half inch of immersion, is that correct?
Yeah.
Is there a certain amount of time you're supposed to wait?
You, once it stops traveling, so
Ready,
You want-
go.
And do you care what order we test these in?
it doesn't matter, as long as there's time.
Okay, we're starting off.
Glass is a little dirty, so it's kind of hard to see.
Wow. You are not saying much.
Centimeters. His highest point.
See how much they
So at least it's rising
Yeah,
beyond
like
what we
one-
submerged
I will
it.
give you a hint. The Kleenex, it has the least height.
Oh.
So don't watch it all day. Not a lot's gonna happen.
Let's say,
So
Half a
that's
centimeter.
1
That sounds good.
1.6 centimeters.
Since we didn't have it submerged enough.
Probably depends if we
We need a
take
dot so we can track travel time.
the texture or the non-texture. Let's take
Little
let's
chromatography
go with
right
the
here.
non-texture. Yes.
Oh. I'm failing today. Half this inch up, thing.
Well, 1.5 inch or 1.5 centimeters. Okay, why don't
You hold the dot. This is so frustrating.
You did good.
So if we go to 29, so no one.
Do you decorate your humble baby?
We want to do.
It's outside my door, and I wanted it, I remember.
Just that slice.
Just cut it off.
You can just trim cut off the ends like. I would trim this little, the second layer off the back, just so it doesn't interfere with the, so it doesn't interfere to your grade.
I'll just put it up, yeah, I just 20 milliliters.
It goes to like 250, so we put it up to the, I mean, sorry, it goes to like this line? So we put it to that line? I mean,
You're
That
okay
line?
with it that way if you want to, half an inch. If it's just touching the bottom, just put half an inch of water.
I'll get it.
I think I was too tired. I couldn't even make some mistakes. It actually wasn't that good. Try again.
I'm still in it.
With the, when you do the colored napkin, it might be easier to view it from the back, from the white side, because you can see the water traveling easier. It's hard to see against the colored background.
Oh, yeah. We'll get it to hang straight now anyway.
Very public squash super fast.
Oh, it's way up here too.
And it's supposed to be pumpkin
Wow,
pie.
I was
Aww.
not.
What? It was
Yeah,
good.
taste, right?
It's just like, you know, I don't think it's so spicy. It's like, I'm usually really good.
It's like a teaspoon of everything. And a can of evaporated milk.
It's just good.
There's not a place for you to record the third towel, so just write it in at the bottom. Just pull it out.
Or we got it going.
It's
Still. Not quite. It's just done.
I mean, it's solidified.
We need to probably come up.
Pen is not chromatographic, by the way.
Come on.
Oh, yeah. No, some will run in water.
Oh, this is waterproof.
I think it's slowed down.
Dumb.
You
You thought I was so smart.
I would call that an 8 centimeters.
I'm gonna take 2
Yeah.
centimeters.
For some reason,
Yeah,
9 minus 3 7.
You measured it already.
Waterproof and
Like,
fake.
everybody had theirs.
It really did
should
not
have
wanna run.
theirs submerged in
No,
this
no
bottom
matter what, it
half,
would
so
not.
you can record all
That's the
those
other
at the
one.
top of the water.
Well,
And it's perfect for
with
the
the other
side.
one, with the other one, we just went from water height up.
Okay, you know, that's fine, as long as you
Oh,
do
it's the
something
same.
consistent, so that you can make
Okay.
a comparison.
Shut up. That is the best movie in the world.
Fine, but we're not vertical.
How are we
So,
friends
I
anymore?
told
it?
Oh,
I
I'm
told
kidding.
it 7.
Have you ever
Okay,
seen
we were
it?
at 9 minus
Greatest
2.
movie of all time.
So it would be 7. It's retarded.
Yeah. Sorry.
And it's gained a little bit more.
It's kind of fun.
Alright, so we just have to fill out to the 275 mark.
Yeah.
Which line did you fill out to?
275.
Yeah, except that.
There's a reason you can buy those colors.
Oh,
Maybe they're higher
sorry,
quality.
7.
Oh, it was a, you
No,
might.
no, I was just, I think you were wrong. It's counting.
Just a hair.
Down.
Oh,
too.
I guess we've just been going on half of
I'm-
the thing up from.
You're not doing the experimenting correctly, I just want to point out that that's 250 and 200.
Oh, got it. I was like, oh, we've just been going up by half a line instead of.
Like it.
That's right.
Gotcha.
Just
You're doing
barely
it
off the
correctly.
bottom,
I
and
just-
we'll fill it up to the same time.
That's well, right?
It'll be 2
That's
centimeters
good.
off.
That's quick.
Is everybody on their last trial?
We
Is
are.
this your third one?
Yep, this is our
your
third.
It's done.
It's like a big pause, not something.
Are we 2 ply on this or we
Yep.
1 ply? There's 2 ply.
Is it a marker?
Oh.
Alright, I'm sorry.
Right there.
Taking off? Ooh,
Yeah.
yes. It's going pretty good.
No.
Boy, this side, yeah, she's see better.
There's the 6.5.
Okay, gotcha.
I can see it.
It's just my
Should we
angle.
figure it out?
It's my light. It's going to turn this way.
I have
Is it
a.
shorter?
Yeah.
Really?
Is it kind of?
Yeah, you must have
Trying to pass it down, that's kind of magic going to the last. I think it is, it's still moving pretty good.
I think that should be
Oh, he didn't do Mr. Yeah.
Yeah, I didn't know. They don't pay attention to what
Too bad.
it was pretty good. Yeah, that one's really great.
No, it's not quite there yet.
Just great.
Look at this guy going down, just getting
Is yours still moving there, Jeff?
I think we're still moving a little, yeah.
Okay.
Oh, sorry.
Doesn't look like it's
Totally
gonna
not.
move as far as the other one.
9.5.
Okay, go ahead and take a minute to record the rest of your data. And I think it's moving slow enough that I think you guys can probably get a pretty accurate,
Thank you.
at least you can make your comparison with your predictions at this point.
And find out how wrong we were.
Okay, we only have a few more minutes, so we're gonna go ahead and wrap it up. So we're gonna record our data here. So I'll start with army ants, and we're gonna call the tile number 1, let's just do the Kleenex first.
Our Phoenix was 2.5 centimeters.
And then the white napkin,
The white napkin was 8 centimeters.
and the color,
9.5.
9.5.
9.5?
I think
Okay, and water rats.
Yeah, but I think that we didn't go.
Okay, let's go to Buttercup. So the Kleenex first,
1.6,
and then the white napkin,
6.4,
and the last.
Okay.
7.5.
Are you guys ready?
Yep, 2.5, 9, and
9 and 8.
8. Yep.
This was the white napkin?
No, I think we switched those
Yeah.
around. It'd be
Oh, I'm
8
sorry.
and 9. Yeah.
So is 2 the white napkin?
Yes.
8 centimeters.
Okay.
8 and 9, yeah. So we added our 2 centimeters on.
Yeah,
Okay.
I think we were just really precise.
So it looks like each group, it was at least consistent that the tissue was the least absorbent, then the white napkin, and then the colored napkin. Did anybody predict that the colored napkin would be the most absorbent? No, that really surprised me myself, actually. I thought, so who thought the tissue will be more absorbent. Really? And so then, water rats, you predicted that the white napkin?
We thought the white napkin would be by far, at least I thought it would be by far the most absorbent because it was textured.
Oh,
That was textured. And
Well,
what's,
actually-
More porous.
go ahead.
Looked more porous. The white napkin it
Okay,
looked visually
so-
more porous.
so the porosity is what we were comparing really with these napkins. So I agreed that I thought the white one seemed like it was the most porous, so I thought it would be the most absorbent. I was quite surprised that the colored napkin actually was the most absorbent, because if you've ever tried to use one of those to dry something, they don't work very well. So when we go back to, we've just talked about cohesion, adhesion, and surface tension. So what property of water did this event demonstrate? So can somebody describe to me what was happening?
So
Jocelyn?
the water was actually having to like fight gravity and climb up the
Exactly.
towel.
The water molecules are climbing up the towel and they're going against gravity. So
So they have
it
to be
is
attracted.
adhering to the paper, but there's another term that we use to describe this. Think about how this would happen in nature.
Cohesion too, like they're sticking in themselves and they're climbing up.
Capillary action.
There we got it.
Yes.
It's capillary action. So where do we see this demonstrated in nature? What's that? Where?
Plane.
Plants. What part of the plant uses capillary action to get water?
The bottom fold.
The root systems. And then Jeff had mentioned the idea of porosity, and if we had soil that was not very porous, would water travel through it very well? No. So it's slower. So if we have porous soil, then water is able to come up through that soil and get to the root system of the plants. And this is called capillary action. And does anybody know where else we might see capillary action?
And like straws.
In straws.
I don't know. If you put like a straw into a glass, you'll see like on the sides it kind of climbs up a little bit.
So when we talked about the kind of the opposite of this, right? If you have a container like a straw and the water is coming up from the bottom, this water is actually climbing up the sides right here. And so that also demonstrates capillary action. And there are actually some like microinvertebrants in stream systems that use this capillary action to climb up the surface of the water to get out onto the land. So basically, the properties of water that we learned today in this lab were cohesion. Remind me again, what's the difference between cohesion and adhesion?
Cohesion is water sticking to itself. Adhesion is water sticking to something.
Right. So water molecules are attracted to each other, and they also stick to other materials. The surface tension is that bond between the water molecules being strong enough to actually support something on the surface of it. And then capillary action is when the water molecules, again, that bond is so strong between them that they're actually able to climb up one another and defy gravity. And I think that's about it.
Okay. How did you like Water Olympics?
Good.
It's really
That was